Question 47. Consider the following concurrent tasks in which each assignment statement executes atomically. Initially, the shared variables x and y are set to 0. Let's make sure we understand terms first. Concurrent tasks means parallel processing. These tasks are going to execute independent of one another. And we don't know which steps within the tasks are going to be happening at what point. So these are concurrent tasks happening at the same time, not one after the other. The opposite would be sequential tasks. You do task 1, then you do task 2. That's not what's happening here. The other one is execute atomically. Some people might be a little nitpicky and say, well, maybe in the middle of updating some variable, something's going to happen. We're not going to do that. Atomically means linearizable. So basically, when the assignment takes place, x equals 1, nothing interferes with that part of it. So each individual statement, x equals 1, a equals y, that happens completely and all the way through. We don't have to worry about concurrency for that particular operation. I hope that's clear about that. So shared variables means that x and y are shared variables. Both of these tasks can share the same x or y variable. So that's going to be important, because even though they're two separate independent tasks, the variables are being shared. So the question is, at the end of the tasks, the values of a and b are examined. Which of the following must be true? 1. If a equals 0, then b has to equal 1. 2. If b equals 0, then a has to equal 1. And 3. If a equals 1, then b has to equal 1. Well, let's take a look here. Just think about this example. Easiest example is, let's suppose they actually did complete in sequence. In that case, the first step would be x would be assigned to 1. So x starts off at 0, but it's going to be 1. Excuse me. And then a gets set to y. Now y is 0, and y has not been updated yet, so a is getting set to 0 now. Now the second part would be y equals 1, so y is assigned to 1, and then or 1 is assigned to y, and then x is assigned to b. X is now 1 from up here. So the point is that a is 0 and b is 1. Now you'll find that if a is 0, the only way for a to be 0 is if x was already assigned to 1. There's no other way for a to be 0. I mean, this statement can't be executed before this. So x gets assigned to 1, then a is 0. And then if that's true, then b could be 1. Actually, b has to be 1 because b is assigned from x. There's no way to make it so that a is not 0 and b is 1. So anyway, so this one's true. Here, the same reasoning would apply if b is 0 and a is 1. If for some reason this process was reversed, let's imagine that we had y equals 1 and then b equals x, which would be 0. And then we have x equals 1 and then a equals y, which would have to equal 1 because y y is 1 here, you can see. So there's no question that if b equals 0, then a has to equal 1. Now the question is, though, what if a equals 1, does b have to equal 1? Well, we could construct a situation where well, actually this is an example here. A equals 1, b does not equal 1. That's an example of a successful execution of this where this is not the case. So that's not true, but these two are true. So the answer then is D. D, 1 and 2.